Welcome to myprojectbazaar.com. Our project title is an energy efficient reliable data transmission scheme for complex environmental monitoring in underwater acoustic sensor networks. Abstract. It is important to achieve high network lifetime in underwater acoustic sensor network. Sometimes it may happen when one or more nodes wants to communicate with sonobuoys means it leads to overhead. For avoiding this situation, we propose KOCA algorithm, which provides non-overlapping situation while communication. So the goal of KOCA algorithm is generating connected overlapping clustering that covers the entire sensor networks with a specific average overlapping degree. For using KOCA, the communication overhead is reduced due to the dropped packets. This is requiring achieving load balancing between different clusters. Also, we propose FNR algorithm, which is fault node recovery algorithm. So, FNR algorithm is a combination of gray diffusion and a genetic algorithm. This algorithm results in fewer representation of nodes and more refused routing path from our simulation active nodes. This algorithm will increase the number of active nodes by reducing the rate of data loss and rate of energy consumption. Simulation results shows our proposed KOCA and FNR provides better results compared than EGRC. Let us see the flow of our project. So in our network we have to split our network into two phases. One for setup phase, there is CS setup phase, next for FNR implementation. So first in beginning we have to form the network depending upon our energy basis and the channel antenna. So we have to split up the cluster head based upon the KOCA implementation algorithm. This algorithm is used for combining the Euclidean distance and weighting information. So it will create the cluster head selection method. So the highest energy efficient node is node, and the distance between the node is highest node is taken as the cluster head node, and all the other nodes are added the cluster members of that cluster head. So next one is FNR implementation. If any node have the node failure means we have to implement FNR algorithm. So the node it first checks the node information using our gray diffusion and the genetic algorithm. So data transmission is done depending upon the FNR information. So if any node have the data failure means other nodes give the boost up energy to that node and send the information using TDMA scheduling process, and the analysis will be done. So for analysis we use throughput, delay, packet delivery ratio and the energy calculation. Let us see the output of our project. For running our project we have to open the VMware workstation and click on this terminal window, then change the directory to our coding folder. So type cd space code and ns space main.tcl for running our tcl file. So when we type this ns space main.tcl it will display the number of nodes set in our network and the position of each nodes for Euclidean distance formula, and it will calculate the updated energy, that is residual energy, and the updated position of each nodes. So this time is for calculating 30 seconds. So now the process is 18 seconds and 19. So after the 30 seconds it will be done. So this will display the updated energy of each nodes. So now the time is 35. So updated node position will be also displayed. So this is our output window which is called a network animation window. play forward button. We have to click on this. This is our algorithm, that is RTS and CTS message will be transformed. RTS is nothing but a request to send, then clear to send message will be transformed. When we click on this play forward means it will be start running our project. So we have to increase this speed as 20 milliseconds. So we form 50, there is 100 nodes. So you have to split the region into our acoustic network into 4 groups, and select the data transmission nodes, and that is the node 39 is acted as a source, and node uh, other node is 0 is acted as a sink. So the node which have the highest energy is taken as the cluster head, and since the transmission is via that node, so now the transmission is done via that node. For additionally, it will calculate the backup sensors and the node which have the lowest energy, and it will give their energy to that node. So now the data transmission. So the one advantage for this project is to it parallelly run the data values in 4 clusters, so no overlapping is done, and we have to use the KOCA and FNR algorithm for identifying the shortest path and identifying the node failures. So for running our graph file, we have to go to that graph. So our graph is click on this root zoom, and this code we have to type on our graph name. So this is our neighbor.txt, which is used for identifying the neighboring nodes. So for that we have to type throughput dot plot. So GNU plot space thr dot plot for running our graph file. So this is our graph file for our proposed algorithm. Thank you for watching.